Good afternoon. Welcome everyone to this session, Migrating Microsoft Applications to AWS like an expert. And let me just get this out of the door. The expert here, I'm not very popular. Expert here refers to the customers who have done it before you. Customers who have run Windows workloads on AWS, what we've heard from them, what has worked well, what are the patterns, practices that can help you, that has helped them run Microsoft applications on AWS. And we're going to share some of those pattern practices and see, hopefully, something resonates with you and you can take it back to your organization. But before that, thank you for being here. I think the entire week, and this is Thursday. It's been a power-packed week, lot of sessions. Hope you enjoyed it. Hope you found time to network with other customers, peers, colleagues, exchange thoughts. And I know specifically for Microsoft technologies on AWS, there have been many sessions this week. So just out of curiosity, if you can have a show of hands, how many of you have attended at least one other Microsoft-specific sessions this week? Wow, a lot of people. You're a tough act to follow. So I'm Giriraj Daga, Solution Architect. I've been with AWS for almost 2 years. I started working with .NET technology. That was my first project, converting a .NET 1.1 app to .NET 2.0 way back in 2006. Crystal report dependencies, trying to work with stored procedures, optimization. So it's a very special moment for me to standing before you here talking about migrating Microsoft applications to now AWS. A lot of change. I'm joined here with my colleague and friend, Rahul Kulkarni. We both work out of Bangalore. I support mostly the large enterprise customers in India, and Rahul works mostly with partners, our GSIs. So collectively, we have worked together, working with our customers and partners, building applications, deploying applications on AWS, and Microsoft application just happens to come up quite a lot. Hundreds of thousands of customers are running Windows workloads on AWS, whether it's Adobe, Pitney Bowes, Kaplan, General Electric, Samsung, you name it. They're running, they trust AWS platform for running their business critical workloads, be it Exchange, be it Active Directory, SQL Server, Dynamics. And this is the 10th year anniversary this year of AWS supporting, helping customers run Windows workloads on AWS. It started way back in 2008 with the Windows Server 2003 available on AWS. So it's been quite a journey, and the customer base just has been increasing. And I'm always curious, even now today when I have a new conversation that starts about migrating workloads on AWS, my first inkling is to go check why are customers migrating? What do they want to achieve from this migration? What are the objectives they have in mind to get us benefits out of the migration? And I've been often surprised by the kind of reactions I've got. For example, I've worked with an ISV personally. They have a product stack completely built on Windows. They were working, they had their colo providers in US, and business started doing well. They were in the financial industry, regulated industry. They had to expand to Canada, and for some, it just happened for them that the colo provider that they were working with did not have data center in Canada. So that was a trigger for them to go out, look for options, what's available. And when they started looking out, they realized they don't want any bespoke solution. They wanted a highly available and performant application, but also somewhere where you can standardize their underlying technology platform. And so that was their key reason, that standardization and global scale, because as their business is expanding, they might be going to other countries. And the global scale of AWS helped them support, align with their business goals. But at the same time, they told me something very interesting that stayed with me. They said, we're also looking to either be acquired or acquire other companies. And that's why we want to be nimble. And as we are growing fast and doing good for ourselves, but we want to be very nimble in how we look at our IT. So that was a different perspective for me. And while very recently I've worked with a large enterprise in India where the director of IT told me that they don't want to be managing the business of routers, switches, the entire data center, they had aging hardware, so they had to do a refresh. So he had to make a call whether to go with high upfront investment or do an OpEx based model. And we usually had that discussion, and what he told me was also, yeah, OpEx is important for me, but it's not just OpEx. What's really important for me is that when I bought those servers 8 years back, and I was running my ERP application way back then, it was good for that age and time, and it performed really well. But over the 8 years, my business has grown. I've added more CPU RAM to those machines, but overall there has been performance degradation from where I was. And while OpEx is important for me, and that's one reason I'm looking at AWS, but more importantly for me is that I can be a highly available performant application all the time. Right now, I'll do a hardware refresh. I go about it in a year time if my business grows really well, and you keep launching new instances, new instance types, new EBS configuration, you just are innovating on behalf of the customer. So we want to take advantage of that. So I just wanted to leave with that thought that while there is a wide spectrum of reasons why customers are migrating workloads on AWS, I do insist that everyone would have to, I think, implore and understand what their migration goals are, and accordingly that kind of guides you through that journey of what choices you make, what considerations you have to select a platform, and during that migration journey, how to go about it. So while their reasons are many, but at the same time, there are some fundamental questions that keep coming up all the time, and I believe maybe some of this will resonate with you. So the first question we typically get asked is, what are the unique capabilities offered by the platform for Microsoft applications? What is that you've developed that helps to run Microsoft applications on AWS? Do you support all versions? Do you support all softwares? Do you support all Microsoft applications? If I have customized applications, let's say SharePoint with web parts or different ISV products, can I run all of that? Do I have to change anything? What's same? What's different? Tell me about it. What are those unique capabilities on the platform that help you run Windows workloads? And then immediately after that, they typically come across this specific concern. Migrating is not new for folks working with Microsoft software, right? We've upgraded OS, we've upgraded runtimes. What lessons we've learned from that is that migration will lead to a period where there will be an overlap. You will be in two environments supporting your current environment and a target environment, and there's a lot of resources and time. If it's a prolonged process, then it's a lot of wasted resources. So your first objective is to understand how long it's going to take, and with that comes how complex it is. What are my critical path, so that if I have to work with my business, make a business case, what are my high risk scenarios? How do I consider all of that? And then once I have that model, what can AWS offer to accelerate that journey? Do you have any tools, patterns, practices that I can take up so that the migration becomes smooth for me and seamless, and I reduce those risks and look at, and specifically after that, how do I optimize? Migration itself doesn't add any business capability. So what are the ways in which I can optimize my workloads on AWS? And then this is really the meat. Migration usually, as I said, those drivers of looking at either cost savings or moving towards agility, usually it's a means to an end. People want to migrate fast, add new capabilities. Some are looking to add maybe get more insights from the data that they already have, look at maybe the best of breed analytic solutions, or maybe add intelligent AI ML, make their applications more intelligent with maybe using directly an AI ML application service, maybe voice enable their IVR or things like that. Add new capabilities fast, and maybe even experiment some things fast for the business. So that's really where they want to be. So then they're looking, but why are they not able to do that today? Because in some perspective, governance and security kind of holds the organization back apart from the infrastructure choices. But that's something they can't give up. You built a lot of time and looked at your industry and your organization, build those controls. You want to bring them over, and you want better. We are living in an environment where there's a lot of threats, a lot of vulnerabilities on a regular basis. So you definitely want a better platform in terms of security and compliance. And we believe at scale that while it is better and you can do it, we'll look at ways in which you can do automated security and compliance controls so that it's a continuous process. So without getting to the point, so in this session, we're going to look at and through a lens of a fictitious customer who runs Microsoft workload and walk through their landscape and what considerations they had to make and what choices do they make. While what decisions they make, it's a fictitious company, so you can obviously give us that credit to make some assumptions. But I think what we want to leave you with is the holistic approach, how you can take those patterns, practices, and tools back to your workloads, see how you can use some of them, and also, more importantly, the considerations, because then you can decide what's best for your workload. And while you start migrating, we also see that patterns start to emerge. And those patterns, the way to bring migration efficiency is to automate. And infrastructure as a code is the new capability offered by AWS that can significantly change how you look at provision, manage, operate on cloud. So we look at that as an approach and the AWS tools to support that, how it can improve the efficiency. And again, there's one key part I would like to highlight there, that while automation will, yes, bring consistency, it will improve your quality because you've automated, you've taken the human error out of it. But I think the more important part there is that it allows you a capability to adapt and be flexible. Because no matter where you start, you have your own learnings, you have other peers learning best practices from the industry. You want an automated process where you can take all these in a normal, continuous way. And that's what we'll look at both in repeatable architecture, using the tools, and also how to build that security and compliance in an automated way so that you can remain nimble and flexible. So get to it, AWS. So we have the most experience running Windows workload on AWS. But what does it mean for you? What it means for the customers is that over these 10 years, we've gone through highs and lows to understand how to optimize Windows workload for cloud. What are the scenarios that are different on cloud? And also, how can we accelerate it for the other customers who are going to join? For example, we've created quick start deployments. Just one-click deployment, you can have an entire Microsoft stack with Active Directory, SQL Server, maybe SharePoint Cloud Farm, all that's stood up for you. Maybe it's afternoon, you launch that CloudFormation template or a quick start and do your work. By evening, after 3-4 hours, the entire stack is ready. You couldn't do that on premises. Those are the, I would say, accelerators that are built in to help you deploy with best practices. Those templates include best practices. For example, we have availability zones. I think this week you've heard probably availability zones many times. But I think the emphasis, we just can't emphasize it enough of how different, what kind of options it enables. So availability zone is a physically separated location. Each availability zone is a cluster of data center. So your fault tolerance there is different. And then they're engineered for physical isolation. But again, what does it mean for Microsoft workloads? If you had to create HA environment for SQL Server currently on premises, the options were to do it maybe on within the same data center, 2 racks, maybe different floors, but that's where your HA configuration for SQL Server was. And then to be tolerant against physical failures, maybe fire, maybe generator electricity failure, you had to take it off-site and you set up a DR. Now if we have a low latency network, which is like miles apart, but it provides you 9 millisecond or less latency, then you can have 2 SQL Server nodes across 2 different physical locations which have different power supply, and those could be still in always on availability group. That can be your HA setup. And then many customers I see, many big enterprise customers, global customers, now they're even considering then one is I have 2 AZs in one region, which is the minimum. Most new regions are coming up with 3 AZs. So if I have my cluster spread across 3 AZs, which is like 3 clusters of data centers, do I even need a DR? If my availability is the, it has offsite, it has a tolerance against physical failures. So that just, again, underlying footprint, the high available architecture, highly available infrastructure enables you to build on top of that and take advantage of that. And all that is codified into those quick starts so that you can start right away from there. So many things like that. I'll not take too much time, but there's documents, resources, managed services, that all these features have been built in with the feedback from the customers, and that we'll go through some of them along the way today and see how that helps to run Windows workload on cloud. So yeah, a lot of features, and quite frankly, I was very excited. This week Andy launched, in Andy's keynote he announced the managed file server for Windows workload, right? That was a long ask from the customers. So I'm excited, but I'm equally waiting when it will be available in BOM, the BOM region, so that we can take it back to our customer closer at home. So Windows is a first-class citizen. Again, I don't want to go through all the line items, but something that's close to my heart. I started as a developer. I like staying in Visual Studio. So I can work out of Visual Studio, build a .NET full framework app or a .NET Core app, deploy it right out of Visual Studio to AWS. If I had been using Azure VSTS or Azure DevOps, I can extend that pipeline and deploy my application on AWS. If I wanted to use the Premier, the serverless compute function, where what's better than no servers, right? I just focus on my code, I deploy, I don't have to worry about my patching, OS, capacity planning. So my blast radius, even my concerned scope is reduced for the security. So nothing like it. And they all support .NET Core 2.1 right now, and even code build, the managed build service, where if I have a team of 5 people or 50 people, how many builds they do, I don't have to do any planning for that. So all these just reinforce the fact that AWS has made it easier to run Windows workloads on cloud. It's a broad set of IT services that help you run in a secure way, highly performant way, your Windows workloads on the cloud. So with that, I'll request Rahul to take you through a journey of migration accelerators.
Yeah, thanks, Giri. Hello, everyone. I'm Rahul Kulkarni. I'm a solutions architect, as Giri mentioned, and I help partners and customers build and migrate applications to AWS, right? So in the next 10 minutes or 15 minutes, I'm going to talk to you about migration accelerators that will help you migrate your applications, Windows applications to AWS, talk about patterns, practices, and tools that not only help you accelerate your migration, but also help you optimize and get the real value of running on AWS, right? And the way I'm going to do this is through the lens of a fictitious customer, like Giri mentioned. It's Unicorn Shop, right? So without further ado, let me just introduce Unicorn Shop.
Isn't that cute?
So Unicorn Shop is an online e-commerce company. It also has a brick-and-mortar store. Now, the motto of Unicorn Shop is to enable anyone with the dream of being a unicorn to look like one, okay? So it is a Microsoft shop, right? It runs business productivity applications, .NET and SQL Server. As Giri mentioned, there are a lot of developers who are using Visual Studio, and they've built custom .NET applications using Visual Studio and .NET, right? But recently, they've migrated their entire exchange to Office 365. So their email is currently hosted in Office 365. So this is the entire landscape. Now, with respect to migration, this is the typical migration methodology. You go with strategy, you go with plan, you go with build and migrate, and then you finally run. So what does that mean? So in strategy, you're evaluating your IT estate. In the plan, that's where you're discovering all the applications. Typically, customers have to understand what are the type of applications that are running in the data centers, right? And categorize those applications into the 6R framework, right? To identify whether it's going to be a rehost or a replatform, right? And then do a build and migrate, which is basically landing zone creation on AWS and migrating your applications. And when you go to run, it's about steady state operations. Now, while strategy and plan are very, very important for migration, our session is just going to be focusing on build and migrate, right? We're going to talk about tools, patterns, and practices that will help you build and migrate your Microsoft applications to AWS. So this is the typical IT landscape of Unicorn Shop. As you can see, it's an e-commerce site. It has COTS products like SharePoint, Dynamics. It has custom .NET applications. Of course, it has Active Directory to manage identities. And it uses System Center Operations Manager, SCOM, for monitoring and management, right? And if you look,
it's a unicorn.
It's a unicorn, yeah. So if you look at Unicorn Shop, though it's a fictitious company, I believe it is very representative of all the customers that we have talked to, right? You're talking about applications with different profiles. Profile 1 are applications which require compliance that have to be treated differently, right? That is number 1. Number 2 is COTS applications, which are commercial off the shelf, which has to be installed. That is number 2, right? And number 3 is your custom .NET applications, which have to be treated differently, where your developer productivity is of utmost importance. Now, with these 3 patterns, let's see how the migration accelerators and patterns can be built, right? So, like I said before, let's assume that Unicorn Shop has completed the strategy and planning, and they've come up with this kind of a migration strategy, right? So the COTS applications will be rehosted. The regulatory application also will be rehosted, right? The custom .NET applications, some of them can be replatformed to use containers, and some of them, they want to be refactored to use serverless components, as Giri was mentioning, right? So this is their migration strategy. Now, how does the migration journey actually start in terms of all the sequence? So typically on AWS, you start with building your landing zone, right? So that means you set up your AWS account, you set up network connectivity, you set up your security baseline, you bring in your Microsoft Active Directory, you enable logging, notifications. So that becomes your landing zone. And once your landing zone is set up, you start migrating your applications so that multiple people, multiple teams can start migrating in parallel, right? So this is the typical pattern that we see customers following while migrating applications to AWS. Now, while this is true, what I want to start with is talk about patterns and practices for Microsoft applications first, right? And the underlying dependencies. And with respect to account setup and other things, I'll be covering it in the next section, okay? So here, I'm just talking about these things. The reason being, you're all here for understanding how to migrate your Microsoft applications. So what are the patterns that AWS has? What are the tools that AWS has? So we want to emphasize on that. So starting off with network architecture, right? There are 2 options that you can use to connect your on-premise data center to AWS. Now, this is very, very critical because you can only migrate your data when you have connectivity options, right? So you have AWS Direct Connect, which is a dedicated connectivity option between your data center and AWS. It gives you predictable performance with scalability. And the other option is VPN tunnels, right? This is over the internet and typically is used as a backup for your Direct Connect, right? Now, with respect to the VPC design patterns, since we're talking about Microsoft applications, now, most of the Microsoft applications, and since we also have regulatory and compliance-related applications which have to be isolated, they will be running on separate VPCs, which are separate network boundaries, right? And while they're running on separate network boundaries, they all have shared resources. These resources could be Active Directory, could be your monitoring tools, your management tools, or could be application proxies, which are controlling egress and ingress, right? So the pattern that we recommend is to centralize those 2 things, in a separate VPC. Now, these has 2 benefits. One is it helps you save cost. You don't have to install all these applications or Active Directory and monitoring on individual VPCs, which are different network. That's number 1. Number 2, it also helps you centralize the entire management of these tools, right? So you have one team that has access to it and can do it. So the other thing is the transit VPC. Now, this is a dated slide, okay, with the announcement of transit gateway. Now, typically, if you have multiple VPCs trying to talk to your on-premise data center, you would require a transit VPC kind of a solution, which was implemented using Cisco CSRs or any of those things. But recently, we announced our transit gateway, which helps you build a hub and spoke model where all your VPCs can connect to your on-premise data center with transitive routing. So what we recommend is to centralize your core shared infrastructure and set up a separate VPC for that. Now, extending on the same thing, the next thing that I want to migrate is, or set up is Active Directory. What are the options that I have for Active Directory on AWS? One is I can run Active Directory on EC2 instances. The other one is when I'm running AWS managed AD. So these are the two options that are available to you, right? And with respect to the network infrastructure, like I said before, you install or you configure your managed AD on your shared services VPC. And the patterns that typically you have for AD patterns are, one is when you extend your entire domain itself, which is very common to setting up a new offsite, right? That is number one. Number two is when you're talking about trust, right? You're talking about federated trust or one-way or two-way trust. So these are the two typical patterns. And in the context of in the context of Unicorn Shop, they went with a managed AD in the central shared services VPC. They enabled one-way trust to their on-premise data center. And since we talked about this before, they had some workload running in Office 365. The way they would authenticate with that is use ADFS to authenticate with Office 365 on-premise. Now, when they decided to run all-in on AWS, they could use ADMT and PES to migrate to move their Active Directory objects and users to AWS, and also replicate their passwords onto AWS. And once this is done, they can actually run the ADFS on the shared services VPC to authenticate with Office 365 applications. The other option that you have is AWS SSO, which is a completely managed services. So you don't have to look at managing high availability for your ADFS. So this is the pattern that you can look at when you have applications where you can have identity on AWS and also work with third-party SaaS applications like Office 365 or Salesforce, right? So the next thing I want to talk about, a building block, is SQL Server data migration, right? The options that you have to migrate your database are, you can run SQL Server on EC2 instances. Now, you would consider this when you want full control on your entire database, or you're running SSIS or SSRS workload, or you have existing licenses that you want to bring to AWS. This is when you would consider running SQL Server on EC2. The other thing is when you're running RDS, which is a completely managed option, which helps do the undifferentiated heavy lifting, which typically is about setting up HA, backups, patching, right, is done by AWS. So all the undifferentiated heavy lifting is not required by you guys. So you can just focus on what is important for you. Now, what are the migration options? So if you're considering the SQL Server on EC2, all the native SQL Server migration options are available to you. So for example, you can use backup restore, import export, but keep in mind that this would require hours of downtime, which is very good for dev test environments. But if you're talking about production environments, you can go with SQL log shipping, a hybrid architecture, or you can use a service which is native to AWS called the Database Migration Service. Now, these three options help you achieve minimal downtime, okay? And when you're using RDS, the migration options that you can look at is backup and restore, import export, or DMS. So these are the options that you look at. With tools, when you're migrating databases are big, right? You can't replicate them over the network. However fast your network is, it's going to take some time. So your initial seed has to be a full backup of your on-premise database. So in order to get that initial seed onto AWS, you have two services that will help you. One is the AWS S3 Sync, Amazon S3 Sync, or you can use the AWS Snow family, wherein you're taking a full backup. Imagine you have a 10 terabyte database. You're taking a full backup, and you're shipping it to us so that we can restore it on S3, and then create an EC2 instance and restore that backup there. So that is one. But in the meanwhile, there are a lot of changes that have happened on your on-premise databases. So you can do the ongoing replication using AWS DMS or any of the existing patterns that SQL Server supports. Now, that's the tools that AWS offers. Now, with respect to optimization, now, one is you can run optimized vCPUs. So when you turn on your EC2 instance, you can say that I just want 8 active vCPUs. So here the example is R4 4x large, which has 16 vCPUs. By running just 8 vCPUs, some of the workloads, SQL Server is very memory hungry, right? So if your workload requires less CPUs and more memory, this is a way of saving license cost. Earlier, we had very fixed T-shirt sizes, and here you can actually say that, okay, my SQL Server with just 8 cores is good enough. That's one of them. The other option is with respect to storage optimization, and this is really important because, as I said before, SQL Server is memory hungry, right? One of the ways you can look at optimizing your storage is through buffer pool extensions or even temp databases, right? Now, we have i3 instances which have NVMe SSDs on the rack, so which will help you achieve very high IOPS between your SQL Server for your buffer pool extensions files or your temp DB. Now, I've personally seen customers and partners save hundreds and thousands of dollars by just moving to i3 instances when you're running SQL Server, because you don't require EBS volumes and PIOPS to make sure that you're saving on that. It's all bundled into the instance. With that, I think I'll hand it. I just want to cover about Unicorn Shop very quickly. Now, for the PCI compliant application, like I said before, the pattern that they followed was they did a full backup and restored on SQL Server. And for the ongoing incremental changes, they used the distributed always-on availability group to migrate their data onto AWS. For the custom .NET application, they used MS SQL Server, and they replicated using DMS. And one of the advantages that they saw by using RDS is they could achieve high availability, or they could meet their RPO and RTO requirements that the business had by just using the standard edition. Now, with that, I just want to talk about building repeatable architectures, which is very, very key. And I'll give it to Giri, who'll take it forward.
Sure. Okay. Thanks, Rahul. Before I get into that, the DMS service, I want to share a couple of points on that. It was launched in March 2006, and since then, more than 100,000 databases have been migrated with that. So just to give you a perspective of how powerful, or what does it mean for you as a tool, as a service, if you want to use that. So you can have a source database. So database migration service, it will replicate your database. So you launch it on an instance, and then you can set your source endpoint. You set your target endpoint. You set up replication jobs. You can do a full backup, full load, or incremental backup. And then you set up those jobs, and you can continue your applications to run on your source database. And behind the screen, it will complete the replication. And once it's complete, once the replication is done, you can do your typical validations, maybe do a row count check. And once you think that, yes, my data, the replication is working, and at that point, you decide how do you want to cut over. Maybe there's a low time for the application workload. And at that point, you just do a flip switch. You turn over so with minimal, like with seconds to minutes, we are talking about, your DNS endpoint can then, if you do DNS switch, now your application, the target database endpoint can become your primary database, and your application can start using that. So it's a very popular service where customers use it to migrate their databases with minimal downtime, and it can work with any SQL Server edition, standard or enterprise. So, optimized CPU, both of us have had there were workloads that were not cost effective to run on AWS. And when we dive deep and we work with them, there are two things we could do. One, not use PIOPS. If you need higher IOPS, there's alternate ways also to do that. You could take a GP2 volume and strip them together. And you compare and consider, if just stripping multiple GP2 volumes together, which gives you 3 IOPS per GB. So if I can strip multiple volumes together, I may have a 200 GB database, but I may have to allocate a 1 terabyte GP2. But then do the cost comparison, like getting a 1 terabyte stripped volume of GP2 versus 200 GB plus PIOPS cost, what is more cost effective? And there is no right and wrong answer. It's just that sometimes one works more cost effective than the other, and you get this, still meet your application performance requirement. So optimization or doing the right selection of instance types, EBS, just those are the typical things we come across and hear from the customer. Those are the missing elements. So if there's few things you can take away, I would very strongly emphasize on just looking, there are a lot of good articles and more focused sessions only around the SQL Server optimizations. But let's say, okay, now we've got the network set up, we've got the AD, we've got the database migration patterns figured out. So we know, depending on the application, we use a right option to migrate. And now we want to do the applications. And application is where we again see a lot of ways to evaluate your considerations, but at the same time, always have an eye out for what you can automate and how to do that in a large, at scale. So one of the ways is to use CloudFormation template. And before I go there, right, just again my developer self, and this is a mental model I've had for many years when I started working in IT. So I, as a developer, I can be sometimes very less confident about my code. I can check in, I do some local testing, and I feel like it's there. Let me deploy it out to the staging environment, and I'll figure it out. I'll test it there and see if it works. And if it works, yay, great. Otherwise, before my boss finds out, I'll just revert it and I'm back to normal. Nothing happened. And what is powering that? Because it's a file. It's a versioned file where I can write my code, I can revert, and I have full control on that. Nothing is irreversible. I can go back to a state that I wanted, which I had to a good point, reference point. Now, that has never been available to my colleagues who were in SysOps, right? Ask them to play around with network firewall rules. They'll say, boss, come back next year. This is not what I want to do on a jolly good Monday. So that's the power that CloudFormation brings to you. What you do is you describe you think of what you need. I need a load balancer. I need a set of web servers behind it. I need an auto-scaling group to cover that web server. Then I need an internal load balancer, which all these web servers should talk to. Then I need an app tier. And then I need a database. And maybe now you think about security groups. Web server security group should not have direct access to my database. That's my architecture best practice. But how do you enforce it on premises, right? We do a lot of meetings, we do a lot of discussions. But after those discussions, does it always remain that way? We have no idea to validate. It's difficult to do that on premises. But here, if you set up a security group, web security group, name it that way, database security group, it doesn't have access, you can constantly run audit on this even later on. And then the app tier security group has access. All this in an order fashion, you can describe that in a CloudFormation template, and that becomes a stack for you. And then you can combine multiple stacks together. And that gives you a file. It's a JSON or YAML file. You version it, you check it in a common repository, you deploy it. And where does it add real value? I go back to my customers where I work with and challenge them that they come back sometimes to me that I've been using F5 load balancer all the time. And I said, okay, that's great, but do you want to try something else? Like, no, I don't want to touch that. Not on my watch. You try that somewhere, other place, and if it's successful in another part of the organization, then maybe I'll consider, but don't ask me to change that. But I say, okay, then let's go migrate your application stack as is. But now that gives you the power. You can go to AWS Marketplace. There may be an alternate product, maybe cheaper, maybe more features, depending on what you're really looking for, or maybe ELB. And you can switch that over and have 2 different stacks, try them out, deploy them, test your application. If it works, it's great. You now have more data points to make an informed decision. So that's the power I see in CloudFormation, that it allows you to build architecture, provision resources, and then make it adaptable, flexible, to innovate, not just for now, but later. But at the bare minimum, those things aside, it's really, really, really powerful. If there is, again, few things that you can take away with this session, I'd say strongly look at CloudFormation, make it your de facto way of building infrastructure or provisioning infrastructure on AWS. The next tool that offers you ability to automate is System Manager. And again, in this session, we are going broad in many places, and we'll go deep dive on key aspects. So we're not able to cover all these features of System Manager, but this is a hidden gem. It's a free service. Nothing gets better than free. It's a free service, and it has many features that just make it so easy to operate Windows workloads on AWS. For example, inventory. If you want to look at all your managed instances and see how many of them are running SQL Server and which version, or you have some other maybe QualSys agents you are running or some other applications you are running, you want to get an inventory out of it. You want to do a select star from my instances and tell me how many instances have this particular application. You can do that. To give you a practical example, maybe there is a CVE, some vulnerability exposed with certain application. Now, what happens now? If a new alert, new blog article comes up that there is a vulnerability in this application, everyone gets on the fire drill, right? It's like everybody in the organization trying to find which server has running this version of my application. But if I could go into inventory, run select star, boom, I get my coffee, this server, now I know I have to quarantine that or do some action on top of that, and I can move on from there. So features like that, we'll look at a couple of them, the automation and patch manager. So automation is a way to, let me take a step back, right? So how do you create images on, the fundamental way you launch an instance on AWS is by creating an AMI. We publish Windows Server's AMIs, you can start from there, but then most enterprises that will not be their golden image. They'll have other ISV products, other solutions, like maybe antivirus, other tools that they would install on that. And this is not a one-time process. It keeps on changing every month, right? As Windows publishes updates, we would update our AMI. It goes down to PV drivers, your other application that you're running. You have to constantly do that update to build your version of your golden AMI. And from that, you will launch EC2 instance. So automation is a feature that can help you do that in an automated way. Automation is just a capability where it will start from an AMI, launch an instance, run a script that you configure it to run. From that, after it has done all that, do a sysprep, take an image, kill that instance, and at the end you have another AMI which has got the new updates that you wanted it to have. And those install scripts could be anything. It could be even an extension of your CD/CI pipeline. Let's say there's an application you want on the server all the time. You're building it with a CD/CI deployment pipeline. You build that, integrate that with automation. As soon as you build that application, you deploy that on this, you trigger an automation job, which will go pull that AMI, launch an instance, install your application, do any pre-post script that you have configured it to do, and then again create an AMI, and you can tag it. Now the power comes that because it's integrated with the rest of the AWS ecosystem, other products and services, you can trigger a Lambda on top of that. So you can have this constantly running maybe every day. Once the new AMI is there, you may have servers running with the previous AMI, right? You may have auto-scaling group with launch configuration, they're already running. So you can now trigger a Lambda and say, okay, I've done my work, I've created a new image which has the right versions of the application that I need. You go now in a gradual format, go ahead and update the launch configuration of all the auto-scaling groups. that this instance is this AMI is part of. So those are the capabilities that just can help you reduce the manual task. And once you make it part of the automated deployment pipeline, it just scales. Whether it's 100 or 10 servers, it doesn't make a difference, right? So some of the things, again, I just described this whole process, but you can take it back and use this as ways to automate tasks to do with your AMIs. One way is to create your golden AMIs. Other way could be in migration. Let's say you have some PowerShell scripts that help you maybe install some applications or configure a particular product. You can start with a marketplace AMI or our base AMI, and then take it through this process where you bring your own PowerShell script that you use on premises, but you make it as part of an SSM automation job, and then it runs on the base AMI, and now that becomes a migration pattern for you. That you start from a clean AMI, configure what applications you need to configure, and then you tag it, because this is a regular continuous process. You want maybe a tag, this is my latest AMI, and then have a Lambda function. You will create a CloudFormation template, as I discussed earlier, with load balancer, web servers, app servers. But the AMIs have been changing. Every time you run this job, I get a different AMI ID. So how do it's a chicken and egg thing, right? I have to describe my CloudFormation template. I need to insert an AMI ID there. If I don't have it, I can't configure. But you can write a Lambda function, and it says, okay, go find the AMI ID with this tag. Okay. App1 web server AMI, I can get that, and it can be part of your CloudFormation init script, where it will map that AMI ID for that web server, and then and there's a blog article that describes that really well if you want to do that. So all in all, these are the tools which can help you automate your AMI creation process or even patch management on AWS. Now this is the secret sauce with which we'll take how Unicorn Shop migrated their application. Server migration service from AWS is an agentless migration service which allows you to replicate your server volumes without bringing your server down. So if you have on-premises environment, hundreds of servers running, you go to AWS console, create this SMS connector. It gets downloaded. It can work with Hyper-V. As of last year, it was only working, the Hyper-V support was not there, but then it was announced earlier this year. I think it was in the last reInvent, that it also now supports Hyper-V. So no matter what you're using for your virtual servers management, you can now use SMS as this SMS agent on that virtualized environment. It will launch a VM, and then it will call that API of your virtual manager, whether it's vCenter, and get the list of servers that are running, push that up. We have a management console. There you see the list of servers. Now you can go to that server, select the servers that you want to replicate, and you can replicate today, you can replicate in future. You can set up, like, maybe replicate this server starting Saturday, and then keep taking the incremental changes every 4 hours. Or now, as of 2 weeks back, it was minimum 12 hours. Now it is 1 hour. So this just changes the way in which you can migrate servers at large scale to AWS. And again, one of the very popular surveys, I've had customers who've spoken about this, and they said somebody came, spoke about this in a meeting. 2 hours later, they migrated 2 application servers to AWS. So it is a very seamless. And how much does it cost? It's free. So why not consider that? But that means maybe there will be some scenarios where it may not work for you depending on the features. You look at it, consider there are other partners, our rich partner ecosystem, because we've been the 10 years of experience now that starts to play a contributing role, where partners have built a lot of ISV solutions which help for niche areas. So they extend whatever services we have, and there's partners like Cloud Endure and others, which can also assist in your migration journey. So with that, this is the process that I just described, that you install an image, and then trigger a job through SMS. And then it creates an AMI. And you can say, I want the last 2 AMIs, if you're replicating continuously. And one consideration there will be that first time when you replicate, because it's a initial seed part, you have to make sure your network bandwidth is available because it's taking the entire server, the block, and replicating it on the target environment, creating an AMI. But once it's done, it only does the incremental changes. So whatever blocks changed, it's smart and intelligent enough to only move that. So from that point on, it becomes effective. So a very highly recommended service. And now with that AMI, whatever we talked about in SSM and CloudFormation, all that can be also extended. So you can take this AMI, just go and launch an EC2 instance, or you can make it part of a CloudFormation template and automation job to trigger that. So that enables this process. You can create, you can start replication job, create an AMI, launch it through CloudFormation template, or use SSM to add more. You can start with a base AMI, maybe a Windows Server AMI or a SharePoint base AMI, and then keep adding what you need on top of that. And the tools that can help you through that journey. And this is actually, yeah, let's look at CloudFormation and System Manager. How do you optimize typical package software? You can't, most of the times you may not be able to use auto scaling. Wherever you can, please do so. But package softwares are otherwise built with a lot of dependency, and you might have some license consideration that you may have to consider. So if some licensing constraints require you to have visibility to the socket, which is typically not available with a default tenancy EC2 instance, you can consider using dedicated host. Dedicated host is a full physical server. You get the full physical server. You can only run one family, like a M4 large across this, or M4 2x large. You can't mix and match the instance type. That's a constraint. So if you do your instance site selection appropriately, and try to cover more than half of the dedicated hosts, sometimes it is more cost effective than running them as on demand. So if there are some workloads which are cost prohibitive to run on demand, one way to look at it is can you use dedicated host, which is a physical rack of server. You would have to definitely look at the high availability constraints there and how do you build high availability. There are patterns to do that. And then also while you're migrating, a lot of the application may be dependent on like a lot of files uploads, blob upload, videos. Do you just take them as is and do the same block attached storage? Or can you start leveraging S3? If it's a .NET application, there is .NET SDK to upload file to S3. So you can just maybe, if it's a, assuming if it's a centralized data access layer code, you can replace that with use the AWS SDK for .NET, upload the file to S3, keep the metadata in the database, and that way you can now optimize. Your storage can be highly durable, available in S3, and then you take advantage of the rest of the S3, like set up the storage types, infrequent access, and all the other advantages of the S3, right? So those are some ways, and now Windows File Server, the FSX. So I've taken a lot of time. We might extend a little bit, but let's. The key aspect around the rest of the application is that you'd look at .NET Full Framework, .NET Core. What is the combination that you have? What are the end state targets that you are going towards? More and more we see customers tell us that they want to go towards .NET Core. It helps you to build a cross-platform application that can run on Linux as well as Windows. But sometimes it's not just at large-scale migration or in the context of migration. It's not an easy task to just refactor the application, .NET Full Framework, what if it's a WCF service? You can't right away now look at it as a .NET Core alternative. So you have to consider those things. But if you can do .NET Core and containerize it and extend your CDCI pipeline, you can deploy that on ECS and ECS with Fargate if it's a .NET Core application. Fargate is a serverless container orchestration. It gives you it does create servers to deploy your containers, but you don't see the servers, so you don't have to manage them. In ECS, if you're doing a launch type of EC2, then you're managing to those instances. You still have to give the love and care to those instances. But if it's a .NET Full Framework app, then you have to go with ECS. So those are choices that you would consider, and that's what Unicorn Shop did. They looked at where they had a lot of change coming, where they had direction to go towards microservices. They started going towards the ECS direction, containerized their application, deployed it through ECS, and extended their CDCI pipeline. And some other places where there was dev test workload, you just needed something to be deployed quickly. They use Elastic Beanstalk to do that. There were some bad jobs that they could consider refactoring and just take that code, upload that to Lambda, and go from there. One thing about Lambda, how many of you here are like sysops engineers working with PowerShell most of the time? Few of you, right? So Lambda also supports PowerShell core. So you don't have, like, choose a language that you love and you enjoy working with, and get started with Lambda. And you can, any sysops jobs, if you're running something to get some files out of a server, maybe some ETL kind of processing jobs, some validation, if you are writing a bad job to run it on an EC2 server or a server, now you can translate that to maybe a serverless compute and do that through Lambda. And there are many ways to optimize if you're running on ECS. Very recently, I think as of 2 weeks back, I mean, I'm just amazed with this feature. EC2 autoscaling group with combination with EC2 fleet. So what you can do is you can create an autoscaling group and say, give me a combination of instance type, because then I have diversity. Give me a C4 large, give me M4 large, but I need this much minimum CPU and this much RAM, and you scale. When my application demand increases, you go ahead and launch these instances. But wait, I want to optimize how much I pay for those instances as well. And that's where I want to use a combination of Spot, I want to use a combination of on-demand and RI. I don't want to figure it out. I'll tell you, take 20% on-demand, 70%, 80% Spot at this minimal price. And then the auto-scaling group makes decisions on your behalf. Based on the configuration that you've done, you've decided what kind of capacity you need, what kind of core and RAM you need, and what kind of distribution you need between on-demand and Spot. And obviously, RI will cover depending on what you have, RI coverage in your account. And now just the equation changes, the cost model changes. If you can run most of the time in Spot, you may be able to get 70 to 90% cost savings on that. And for that, you just had to make those initial selections, and after that, auto-scaling group does that for you. So really, really powerful feature. Just recently launched. I would encourage to explore that further for your application migrations. So again, these are some choices that Unicorn Shop made for themselves. So in the interest of time, I'll skip that. Monitoring is important once you've migrated the applications. And your initial starting point could be your SCOM, like there's an AWS management extension pack that you can install for your SCOM, and you can continue to use that. But more and more we hear from the customers is that while that's a good starting point, I get a single pane of glass to like look at my on-premises instances and the instances running on AWS. But the operating model in cloud is very different, right? You're adding instances, you're removing terminating instances, you're working on serverless, you're looking at ECS, tomorrow you might look at something else. All those gamuts of things, maybe sometimes, and then triggering lifecycle. Based on lifecycle, I said, as you launch an EC2 instance, you create an AMI, you update it, you create a tag, and then the Lambda comes in and makes it updates the auto-scaling groups. Some of those things, to monitor it more effectively, you need a cloud-native tool. And that's where CloudWatch comes in pretty handy, and the multiple other logs where it can, CloudWatch agent can centralize your logs from multiple sources, be it Windows performance counters, be it your Windows event logs, be your custom application logs. You can just map your CloudWatch agent to those reference points, and then it will move those data to CloudWatch logs. And in the CloudWatch logs, then you can set some metrics and alerts. Set some thresholds. If it breaches certain threshold, send me an alert, or create a dashboard like on Elasticsearch or Kibana, or get some insights of how many times something has failed, how many times unsuccessful attempts have been made to log on to the server, put that onto a quick site dashboard, or use a Lambda to put it on. If you have a Slack channel for sysops guys, and you just, now Lambda can talk to that Slack channel as soon as the data comes in, and based on the threshold breach, it can now pop up a chat box interface that this is something that you can consider. So all allows you to do multiple different ways. So I think the message here that I want to leave you with is that there are many ways to bring your application code on AWS, while you can scale with server migration service and do large scale migration very quickly. And please do consider that and look at it if you go back. And then you can re-platform, look at containers with ECS and the auto-scaling group, and as well as you can just start with your functional code and start building serverless applications and just go cloud native. And this is what Unicorn Shop did. And the considerations and how you make those decisions will be different, but at least hopefully you get a perspective of what are the options. And while we look at the server, but never you would actually migrate thinking servers in mind, right? It's not like I say, okay, get all my web servers and I'll figure out when I have to do the middleware or database. You're always thinking in the context of an application. My application has these many servers, these web servers and all that. You want to track that at that level. That's where AWS Migration Hub comes in. It can help you track your migration journey at an application level and give you a centralized place. And it doesn't necessarily, you don't have to necessarily use the SMS service. It's integrated with some of the partner solutions like Cloud Endure, I'll have to look it up, but I think that few partner solutions that it's integrated with. So whether you use server migration service or we also have an application discovery service, you're definitely welcome to use that and encourage you to use that. But then if you want to use some other services, it's a growing ecosystem where you can then track it in one place. So those are typical concerns again with migration. How do I have one central place to understand how many servers have migrated, how many are in progress, what are remaining, and that at an application level, not at the server level. And look at the failed jobs, what failed and who has to do the next task there. So many other, we talked about few tools and services, but there are many other services. Again, those are the considerations where you may want to engage with a solution architect or an AWS contact you have, or just go out and explore what's available to help you in this journey. So we looked at, we understood the journey, why we are going. It's important to know why we are going, where we are going. We understood now how we can get there faster, how we can optimize the downtime, how we can reduce risk. There are a lot of tools and services available to support customers migrating Windows workloads. And then really where rubber hits the road is this. You want to now move fast and stay secure. How do you do that? So once you go back and let's say you've done all this work and now you start growing, right? So you have account sprawl, a lot of AWS accounts, and now if you have to control the identities in each of these accounts, how would you do that? Like who has admin access on this AWS account? And what is dev, what is non-prod, what is prod? And this just could be very scary, right? But that's where AWS organization, if you've not considered, that allows you to do a central account management. You can, how would you typically think about your organization, right? Maybe it starts with the CEO, there are VPs, there are directors, they have separate responsibilities of the organization that they work with. And then you just map that into AWS organization as OUs, organization units. And then you map accounts to those OUs. And then you start applying what is called service control policies at the OU level. So you can say dev OU is allowed to have maybe $500 per month budget, and that applies to each of the accounts under dev OU. You can say dev OU, the developers in this AD group has full access, and you map those roles. You can see I have prod and prod PCI here in the context of Unicorn Shop because the compliance regulatory requirements are different. There are not all the AWS services may not be compatible with the PCI, right? I want to only whitelist the services that are PCI compliant so that just, I don't leave it to the developer to figure it out. I can set those as policies. Let's say for example's sake here, if I say only allow calling an EC2 API or a CloudWatch API, which will be too restrictive. I think people will be looking for me if I do that. But that's just that goes to say that what you can do with security control policy, service control policies on OU to control access in a centralized way. So now once you have this, you can distribute that to like those, you're thinking in a more logical way, easier way, and then applying it to multiple accounts. Once you do that, other ways, when we start typically, you might have come across a pattern called cross-account roles pattern, where if I need to give you, I'll maintain one central identity account where that's where I'll create IAM users. But then on all the other accounts, I'll create roles. Like he's a developer, he's a sysops, he's production support, break glass, infosec. I create those roles and then I map. This identity user can assume this role in this account. So I allow a way where I'm just defining roles in the target account, and I define the permissions that that role can have. InfoSec can have full access, and developer can only call EC2 and only launch type T2 instance and things like that. I can influence what it does. It's easy, it's a good pattern to start with, but this gets out of the way very quickly when you are talking about multiple accounts. Because what if I have to change permission of what admin means in a non-production account versus a production account? I have to now go and change the role in that one account. If it's one account, it's okay. It's 5 accounts, it's okay. Once it starts to get 20, 30, 50, 100, it becomes difficult to go change the roles in each of these accounts. That's where stack sets, the CloudFormation stack set comes in very handy. It can help you define your, it can again becomes one centralized template of all the controls that you need to implement in the account, and then map it to deploy it across multiple accounts. And security is never just at the time of launch, it has to be continuous. You have continuous threads. You have a service called guard duty, which can track, it uses machine learning technologies. You enable that with one checkbox in your account. It goes and looks at, baselines it for 30 days, and then looks at what's going on in your account. Maybe you always had traffic coming from a subnet, web subnet to a database subnet, and then suddenly the traffic boost from some other place. Somebody's trying to clean up its trace, trying to disable CloudTrail, then that seems something fishy there. It can start sending those findings as alert. It can show you those findings, and then it gives a severity rating between 1 to 10. 1 being the least severe, you may find a lot of observations, 10 being very severe, and you want to take some actions on top of that. So you just create a rule. These are commands, I'll leave it on the screen, on how to move those findings onto maybe a CloudWatch event. And once those events happen, then you can map it to a SNS notification, get an alert, or create a Lambda function that can do a corrective action if you so choose to do so. Maybe quarantine, maybe map that security group to only InfoSec team so that they can do, or maybe do forensics, take a copy, move that EBS volume into a forensics account. So you have mechanism, once the findings are available, you can connect them to the rest of the AWS ecosystem. You can choose to use any thread management system that you're used to, or you can also look at web application firewall from AWS. It's a managed service. And the other perspective is you can use managed rule sets. There are partners who have built PCI or for many different categories, they've created rule sets. So they're looking at all the threats in the market and then creating rule sets. You may not have the right, you may not want to invest in that kind of resources, or you may not have the intent to do that. Now you can just use a managed rule set from the partner, from the marketplace, and apply that on the WAF so that somebody else is managing that and it's dynamic, and you have continuous compliance of the latest industry findings. So all this, I'll summarize that basically it will mean that you have to create your own baseline for what's your account, what's your network baseline, how do you give access to users, what do you do after that. All that you have to determine what's the landing zone means for you, and then create an automated process for all this to come together. Everything is an API, and there are reference solutions of how to build a landing zone. You can look it up. I think I may have the link in the resources. So with that, we have a few minutes over already, but I think we just are wrapping up. If you can give us a few more minutes, I think we should not be more than 5 minutes.
So we have a quick demo.
So while he's bringing up the one, okay.
So we talked about organizational policies, AWS organizations, right? And this is how it looks like. So we have prod PCI, and non-prod. And in case I want to deploy, for my PCI applications, I want to make sure that I have encryption turned on. Any EC2 instance with EBS volumes that are launched in that instance, in that account, needs to have encryption turned on. And the way I would enable that is using stack sets. So I go and I create a new stack set. Okay, we have a number of sample stack sets. So I just look at this and hit on next. I give it a name. and I can specify which particular region that I want the stack set to be deployed on. Not just that, I can copy paste my OU ID, right, which is here, to specify that this stack set should be applied only on this OU in this particular region. So those are all that is the power that I have with stack sets. These updates need to go only on this specific accounts, right? So, and once it goes, the accounts, here we are talking about AWS config. Now, I've just done the stack set deployment previously in the interest of time. So it shows me that 3 of my existing volumes have not been encrypted. And this is controlled through a centralized place, which is my root account. And the stack set went and deployed this rule, which is the config rule, which looks at my infrastructure and figures out what are the things that are deviant and gives me a dashboard like this. So three of these EBS volumes are not encrypted. And based on this, I can take action. I could actually trigger a Lambda function to do something, or I can notify people saying that these volumes are not encrypted and we're not being compliant. So that's a quick demo that I had. I didn't want to spend too much time. Now then, so what we started with, right, is giving them patterns, practices, and tools, and giving you building repeatable architectures and continuous compliance. That's the promise that we said, right? We'll give you patterns, practices, and tools for migrating Windows applications to AWS, how you can build repeatable architectures with CloudFormation or Systems Manager, and use continuous compliance using our landing zone solution. Now, putting it all together, right? So the way we look at achieving continuous compliance is when you have AWS and your AWS landing zone, which is your landing zone where you control how you want to configure your entire AWS environment as a means of achieving continuous compliance. With respect to building repeatable architectures, we're talking about CloudFormation and AWS Systems Manager to help you build repeatable architectures to get the maximum value out of your migration to AWS. And then finally, the patterns, practices, and tools. We talked about how you can bring your network, your Active Directory, SQL Server, COTS applications, and custom applications. But I just want to talk about asking a friend. I mean, this is your call to action, right? As Giri said, we have 10 years of experience, and not just us. Our partners also have 10 years of experience in migrating Microsoft applications to AWS. Speak to a solution architect, speak to a partner, and these are the list of partners that you have who are certified on our APN network.
Yeah, this could be representative. I think we'll encourage you to go to the website.
Yeah, go to the website and get started there. With respect to key takeaways, with Microsoft on AWS, continue to use your familiar tools on AWS. Build a landing zone with automated security and compliance controls that we talked about how stack sets and landing zones are very powerful. Start small and be iterative. Look at one specific account. Automate, automate, automate. That is the best way you can actually get value out of your migration to AWS. And leverage managed services where possible, like RDS. And leverage the partner ecosystem and the AWS marketplace where possible. Yeah. So here are the resources, and thank you so much.
Thank you. I can only say that you're in a good company. Please leave feedback on the mobile app.
Yeah, please do give us feedback.
If you have any questions, we'll be on the side.
Yeah, we'll be on the side.